Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we should be having a look at polynomials, and to be entirely specific, we'll be looking at the division of polynomials as well as the factor and remainder theorem. So without further ado, let us begin. So what exactly is a polynomial? So a polynomial is nothing but an equation which has well, to define it simply, it's an equation really. We could say ax plus b equals to 0 is a polynomial. Ax squared plus bx plus c is also a polynomial, and so on and so forth. But how do you go about the divisions of these types of polynomials? Now, if we recall, when you are dividing, you have something like this. Let's say you have some sort of number over here, 77, for example, and you have, let's say, 11. You want to divide 77 by 11. We know that 11 divided by 77 gives us 7. 77 divided by 11 gives us 7 as the answer, and we put our 7 over here because we say that this over here is our quotient. That is our quotient in terms of division properties. And suppose it was not 77, let's say it was 78, for example. Then we know that 11 times 7 is 77. You do your normal primary school math, you get 1 over here, and then we call this our remainder. And as we know, whatever that is being divided, in this case now 78, we call this our dividend. So these are just the basic terms that you should know, because they will really make your work easy when dividing polynomials. Now, how does division of polynomials go? It can go to a lot of extent, but for this video we'll be just having a look at the format of division of polynomials in the form of x plus, let's say, any constant, let's say p, x plus p, and we're going to be dividing, for example, maybe ax cubed plus bx squared plus cx plus d, for example. So this is the main type of examples we'll be having a look at in this video. Of course, this can vary. Sometimes on the outside over here you can have a quadratic, for example ax squared plus bx plus c. Sometimes you can have a quadratic without a constant of bx, so you can just have ax plus c. So there are different ways of doing it. Maybe all that will be done in a later video of mine, but in this one we'll just be having a look at x plus p, because this is the most common type of division. Now, the way we go about this is we have a look at what we can divide and what we get by dividing, so that we multiply it by it. Now, all of that sounds very confusing at first, and this is a topic that's mastered eventually by doing examples and examples, but I'll try and make it understandable using this basic division over here. So how exactly it works is that at first you would do ax cubed divided by x. Ax cubed divided by x. If we just have a quickly look at that, ax cubed divided by x, we know x, this will become x squared, and this x will cancel out, so we will have x squared, ax squared over here. Now that whenever we do that, now we see what's ax squared times x, and that should always give you the answer over here. So ax squared times x gives ax cubed, yes, and then ax squared times p gives us, let's say, plus p ax squared. And we know from our normal division that we always subtract over here. So using the same fundamentals, we subtract. Ax cubed minus ax cubed is 0, so we have 0 here. Bx squared minus p ax squared, that would eventually give us bx squared 0 minus PAX squared. Now all of this looks complicated with all the P's and B's and A's because I'm not using actual values at the moment, but this is how the ground foundation of it works. Now whatever this will be equal to, you then divide this by x. So we know whatever this is, we have x squared in common. So let's say all of this bx squared minus pax squared is equal to, let's say zx squared. Dividing zx squared by our x, again, our x and x will cancel out, so we'll just be left with zx. So plus zx. And now again, you do zx times your x, which would give you zx again. And remember we said this is zx over here, so we have zx minus our zx again, and then zx multiplied by our p, which gives plus zxp. And remember, you always bring down your cx as your normal division standards and your normal division rules, and then you go on again, this and this will cancel, so we'll have 0 again, and then whatever plus c minus zxp is, and you again do the same method until you have another value, and most likely it will be a constant over here. So all of this is very confusing at first, but let's go right ahead and dive into examples, because the more examples we do, the better it is understood. Now this is the division of polynomials. There's another way of doing all these questions using the factor and remainder theorem, but we'll be having a look at that later in the video. At first we have to master our division skills. So let's look at the first example. It says for the polynomial f of x equals to x cubed plus 6x squared minus 9x minus 14. And then part A says divide f of x by x plus 7. Right, so let's go right into this. We have x plus 7, and what our dividend is x cubed plus 6x squared minus 9x minus 14. Now first step, you take your x cubed and divide by x over here. So x cubed divided by x gives me x squared. And I know that's correct because when I do x squared times x again, x squared times x again, it gives me x cubed, and that's what I want, because I want to eventually cancel these x cubes out so that I can have a 0 over here. X cubed minus x cubed gives me 0. And now I do it with the other number here, so x squared times 7, and that gives me plus 7x squared, and then 6x squared minus 7x squared, and that gives me minus x squared. Do be very careful of your signs. Now we have minus x squared here. We now bring down our minus 9x, and again we now do the same. We do minus x squared divided by x, and minus x squared divided by x gives us minus x. And I know that's correct because when I do minus x times x again, I get minus x squared again over here. And when I eventually subtract them again, minus x squared minus minus x squared becomes 0. And then minus x times plus 7, that gives minus 7x. So I have minus 7x over here. So minus 9x minus minus 7x, that's minus 9x plus 7x, and that gives minus 2x. And now I bring down my final term, that's my minus 14. Now again, what's minus 2x divided by x? Minus 2x divided by x is minus 2. And I know that's correct because minus 2 times x then gives me back minus 2x. And when I am subtracting, minus 2x minus minus 2x gives me 0. And minus 2 times 7, that's minus 14. Minus 14 minus minus 14 gives me 0 as well. Now whenever, in terms of a remainder, when you have 0 as a remainder, that means the equation that you've divided the polynomial by, in this case x plus 7, is a factor of the polynomial x cubed plus 6x squared minus 9x minus 14. Whenever your remainder is 0, that means it's a factor. You can look at it with this example over here. If we divide, let's say, 99 by 9, we know we do 9 times 11, which then gives us 99, and our remainder is 0. And we know that 9 is a factor of 99. That's why we know it, because the remainder is 0. And over here, our remainder is 0 as well. Hence, x squared minus x minus 2 is a factor of x cubed plus 6x squared minus 9x minus 14. And we can just simply write this as this x plus 7, so that eventually when we open these two out, we will get our polynomial over here. Right? Now for the b part, it says find the remainder when f of x is divided by x plus 3. Now again, as I said, the factor theorem and the remainder theorem will be very handy while doing this, but we can try doing it the long way first. That's by division of polynomials. So finding the remainder when f of x is divided by x plus 3. So let's just do that right here. The same polynomial is what we're working with. That's x cubed rather. X cubed plus 6x squared minus 9x minus 14, and this time it's being divided by x plus 3. So again, just using our basic rules, we go ahead and do our division. X cubed divided by x gives us x squared, and then x squared times x gives us back our x cubed, and then x squared times 3 gives us plus 3x squared. Remember, you're subtracting, so x cubed minus x cubed, that's 0. We can leave it, we don't need to write anything there. And then 6x squared minus 3x squared gives us 3x squared. Next, you bring your minus 9x down, then you take a first term over here. 3x squared divided by x gives me plus 3x, and then 3x times x gives me 3x squared again, and 3x times 3 gives me plus 9x. And then you go ahead and subtract again. 3x squared minus 3x squared is 0, minus 9x minus plus 9x gives minus 18x. Again, you bring down your final term, minus 14, minus 18x divided by x gives minus 18, minus 18 times x gives minus 18x, and minus 18 times 3 gives minus 54. So you subtract, this will cancel out again, minus 18x plus 18x is 0, and minus 14 minus minus 54, that's plus 54, is 40. So the remainder it asked us to calculate is 40 for this example. That's what it asked, I believe. Yeah, find the remainder when f of x divided by x plus 3. So the remainder was 40. Right, on to the next example. I'll just make this smaller. Alright. So this one says the cubic polynomial f of x is defined by f of x equals to 4x cubed minus 7x minus 3. Find the remainder when f of x is divided by x minus 2. Right, so go ahead and do our trick again. X minus 2, 4x cubed plus 0x squared, I'll come back to that in a minute, minus 7x minus 3. Now as you can see, I've added a 0x squared over here, and over here they didn't signify any sort of x squared. Now you can do it without the 0x squared, but I prefer writing it down in the polynomial because eventually it means the same thing, but it makes your work a lot easier, and it's less harder for you because your chances of getting confused in the question is less, because if you don't include the 0x squared, you might accidentally skip a step in the division, and that can lead to a false answer. So that's why it's always safe to put the 0x squared as well. Helps you to stay on track of the right answer. So let's go ahead and do this. 4x cubed divided by x, we have 4x squared. 4x squared times x, that's 4x squared. And then 4x squared times minus 2 is minus 8x squared. We subtract 4x cubed, sorry, this is meant to be cube, sorry. Minus 4x cubed is 0. And then 0 minus minus 8x squared, that's plus 8x squared. 8x squared, we bring down our minus 7x. That's squared. 8x squared divided by x gives me plus 8x. And just to emphasize, we had 8x squared, and I expect you guys to know this. 8x squared divided by x, the x and x cancel out, so you're left with 8x eventually. So that's how we got that. 8x squared divided by x gives 8x, and then 8x times 8x gives 8x squared again. And 8x times minus 2 gives minus 16x. And you go ahead and do your subtraction again. Minus 7 minus minus 16x, minus 7x minus minus 16x, so you add the 16x, and that gives 9x. Bring down your minus 3. 9x divided by x is 9. So you have plus 9 over here. And you do 9 times 9x again. And 9 times minus 2 is minus 18. And you subtract. And minus 3 minus minus 18 is 15. So the remainder, when 4x cubed minus 7x minus 3 divided by x minus 2, the remainder you get is 15. And once you do get the remainder, you can then say, if the question asks, then you can say that x minus 2 is not. It is not a factor of 4x cubed minus 7x minus 3 because it's giving a remainder. If it does not give a remainder at the end, then you can say it's a factor. But since it is, then it's not a factor. Now then, as promised, we'll be now having a look at the factor theorem and the remainder theorem. Now both of them go hand in hand. Let me just write here, factor and remainder theorem. Not sure about the spelling, but it should be something like that. So factor and remainder theorem. Now, the way we did the division of the polynomials is correct, but it's quite a long method, and it can eventually be used for a different type of question, which we will have a look at in the last example of this video. The factor and remainder theorem makes our work super easy. Let's say I have a polynomial in the form of ax cubed plus bx squared plus cx plus d. And it tells me to divide this polynomial by, for example, x minus 4. All I have to do, instead of the long division, just equate my x minus 4 equals to 0, solve for my x, that's x equals 4, and just substitute my x values into the various x's over here. So we have 3 places of x here, and x cubed, x squared, and x. Now what the factor theorem says is that when you substitute the value of your x into your polynomial, which in this case is this, then you will get 0 as your final answer. That is, if x minus 4 is a factor of this polynomial, then when you substitute the equation of x, in this case x equals 4, into the polynomial, you will get 0. And what the remainder theorem suggests is that when you substitute x equals to 4 into this polynomial, then you get a remainder instead of 0. That means that x minus 4 is not a factor of this polynomial. If you get a 0, that means it's a factor. If you don't get a 0, that means it's not a factor. And remember, you're not substituting minus 4, you're substituting x minus 4 equals to 0. So you solve for your x, which is 4, and then you substitute that. Very important. Quite clear concept in this, but let's go ahead and look at some examples for this as well. Right, so for the first example, under this we have the polynomial f of x is defined by f of x equals to x cubed minus 9x squared plus 7x plus 33. Okay, good to know. Part I says find the remainder when f of x is divided by x plus 2. Now, we did something similar earlier in the video in terms of the long division method, but let's now have a look at it the shorter way. It says find the remainder when f of x divided by x plus 2. Our f of x is x cubed minus 9x squared plus 7x plus 33. And it said it's divided by x plus 2. And like I said, don't just go and substitute a 2. Equate what you're dividing it by to 0. And then x in this case is minus 2. So you now substitute your x as minus 2 into the various positions of x's over here, here, and here. And the question says find the remainder, hence we are meant to get a remainder from this. So substituting minus 2 into the x's, we have minus 2 cubed, minus 9 into minus 2 squared, plus 7 into minus 2, plus 33. Minus 2 cubed is minus 8, minus 2 squared is 4, times minus 9 gives minus 36, minus 14, plus 33. Minus 8 minus 36 gives minus 44. Minus 44 minus 14 gives minus 58. And you add 33 to that, should be minus 25. Let me just confirm. Yeah, it is minus 25. So the remainder you get is minus 25 when you divide this polynomial by x plus 2. So eventually, in this case, we use the remainder theorem. Now, the polynomial f of x is defined by f of x equals to x cubed minus 9x squared plus 7x plus 33. Okay, we know that. Part I says that show that x minus 3 is a factor of f of x. Now, like I said earlier, when it is a factor, that means when you equate this to 0 and put the value of your x into the polynomial, you should get 0 as the final answer. So we have x cubed minus 9x squared plus 7x plus 33, and this time we're using x minus 3, and x minus 3 equals to 0, so our x is 3. So what it's saying is that since it's saying show that x minus 3 is a factor of f of x, it means that when we put our 3 over here, and over here, we should get 0. So let's go ahead and confirm that. 3 cubed minus 9 into 3 squared plus 7 into 3 plus 33. 3 cubed is 9 minus 3 squared, sorry, not 9, this is 27. 27 minus 3 squared, that's 9 into minus 9, that's I'm pretty sure about minus 81 plus 21 plus 33. And going ahead and putting this all into our calculator, we get 0. So hence, we have proven that x minus 3 is a factor of this polynomial, because when we substituted x equals to 3 into the polynomial, we got 0. They kind of gave us a hint by saying show that it's a factor. Sometimes they can say that prove or not prove whether or not x minus 3 is a factor, and since we got a 0, then you would now say hence x minus 3 is a factor of the polynomial. If we had gotten a remainder, then you would have said hence x minus 3 is not a factor of f of x. On to the next example. We have a cubic polynomial f of x is defined by f of x 2x cubed plus 3x squared minus 17x plus 6. Okay, good to know. Find the remainder when f of x is divided by x minus 3. So again, we have our 2x cubed plus 3x squared minus 17x plus 6, and it said when it's divided by x minus 3, so x minus 3 equals to 0, x equals to 3. So we substitute x equals to 3 into the various positions over here. We're going to have 2 into 3 cubed plus 3 into 3 squared minus 17 into 3 plus 6. We know that this x minus 3 is not a factor of the polynomial because it says, the question says find the remainder. So eventually we're meant to get not a 0, basically. So 3 cubed is 27 times 2, that's 54. Plus 3 squared is 9 times 3, that's 27. Minus 17 times 3 should be 54. Let me just confirm. Minus 17 times 3. 51, sorry. That's minus 51. And plus 6. So doing all that, 54 plus 27 minus 51 plus 6, that gives 30 as our remainder. So find the remainder. Yep, we've done that. The remainder is 30. Now, had we done this the same way using the division method, the long division method, we would have gotten 30 as well in the end. But you can see how much quicker and how much more effective this method is as well. Also, another thing to add, you can also sometimes get something like 3x plus 2 as a factor, or 2x minus 1. So all you have to do is just, again, same method, just equates to 0. In this case, your x would simply be minus 2 over, sorry, this would be x equals to minus 2 over 3, and in this case it would just be x is equal to 1 over 2. So nothing much difficult about this. So on to the final example of this video. It is a slightly larger example, larger in the sense it requires a bit more technicality. And this is a challenge question. So do pause the video and have a go at this by yourself, and then resume the video to see if you're correct or incorrect, and if you are incorrect, please take note of your mistake. Right, so let's get right to it. The cubic polynomial 2x cubed plus kx squared minus x plus 6 is denoted by f of x, okay? It is given that x plus 1 is a factor of f of x, okay, good to know. So part R says that show that k is equal to minus 5 and factorize f of x completely. So our polynomial we have is 2x cubed plus kx squared minus x plus 6. Now, we don't know k. However, they said that it is given that x plus 1 is a factor of f of x. X plus 1 is a factor. So x plus 1 equals to 0 and x equals to minus 1. What they're trying to say with that statement is that when we substitute minus 1 into our x in the polynomial, we are meant to get 0, because it says that x plus 1 is a factor of f of x. And as I had mentioned earlier, if it is a factor and you equate that to 0, whatever you get for x and you substitute into the polynomial, you will get 0. So what we can simply do is substitute our x into the polynomial and equate it to 0 to find our value of k. So we have 2 into minus 1 cubed plus k into minus 1 squared minus into minus 1 plus 6. And we know that this is meant to equal 0, because as I said in the remainder theorem, the factor theorem, if it's a factor then you get 0. Now minus 1 cubed is minus 1 times 2 is minus 2 plus k, because minus 1 times minus 1 is positive 1 and times 1 is k, plus 1, because minus times minus 1 is plus 1, and then plus 6 equals 0. And collecting your like terms and equating for k is 5. Minus 2 plus 6 is minus 2 plus 6 is 4, plus 1 is 5, and then take 5 to the other side becomes k is equal to minus 5. So we have proven that k is equal to minus 5. It now says factorize f of x completely. Now we have one of the factors, which is x plus 1, but we don't have the other factor. So all we do is we take our x plus 1, and as our dividend we now take the equation of the polynomial, which is 2x cubed. Don't forget our k is minus 5, so we now have minus 5 x squared minus x plus 6. Now when we do this, the quotient that we will get will be quadratic, and that quadratic will also be a factor of the polynomial. And if we break the quadratic into two separate linear equations, as we know from our rules of quadratics, then we can have three separate linear equations or expressions that will then be equal to the polynomial as the factor. So going ahead and doing this, 2x cubed divided by x gives me 2x squared. 2x squared times x is 2x cubed, and 2x squared times 1, that is plus 2x squared. Subtracting 2x cubed minus 2x cubed is 0, minus 5x squared minus plus 2x squared, that should be minus 7x squared. You bring down your minus x. Minus 7x squared divided by x is minus 7x, and minus 7x times x again is minus 7x squared. Minus 7x times 1 is minus 7x, and you do your subtractions, that's 0, and then minus x minus minus 7x is 6x plus 6x, and you bring down your 6. 6x divided by x is plus 6, 6 times x is 6x, 6x times 1, 6 times 1 is 6, and then you do your subtraction, this should give 0. We know it's meant to give 0 because they said that x plus 1 is a factor, and when it's a factor, the remainder is 0. But what we needed was the quotient, and now we have it. That is 2x squared minus 7x plus 6. So eventually what we're saying now is that 2x squared minus 7x plus 6 multiplied by x plus 1 would give us our polynomial, back to our polynomial. But the question said, if you pay attention, factorize f of x completely. If you leave it like this, you may not get all your marks. So now what we have to do is we have to break down this quadratic into its two separate linear expressions. So doing that, we now have something like this: 2x squared minus 3x minus 4x, those are two factors, plus 3 into x plus 1. We then have 2x, sorry, not 2x, we're going to have x into 2x minus 3 minus 2 into 2x minus 3, all into x plus 1. And factorizing this further, we'll now have x minus 2 into 2x minus 3 into x plus 1. Hence, this is the final answer because we have factorized it completely to its most simplest terms. Now, what this means is that if you expand all of them out, then you will get the polynomial. Now, there's no need to do it because I know this is the correct answer, but if you want to confirm and you have time in the examination scenarios, then you can go ahead and do that. And that indeed brings us to the end of this video. Thank you for watching. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching, guys. Have a nice one.